So for finding the optimal solution, I just enhanced an array and I just took one more additional target that is of 10. So what's my intention was whenever I see or whenever I standing in an element, I will try to store that element into a particular hash map. The reason I was just storing that element into a hash map is, as you know, the search space in a hash map is of O of 1. So instead of linearly, whenever you have been standing in the middle, instead of linearly traversing across the array again, we can able to search that element inside the hash map itself. So that's the main intention for me to store each and every element in the hash map. So how you wanted to store that element? All I wanted was, since the problem is expecting me to return the indices, so I just wanted to store the indices that has been in the hash map itself. So when I'm just standing in the 2, since there is no past data, I'll be able to store in the hash map. And in this one, since the target is 10, I'm just expecting for a particular number which should be reaching my target. So that particular number is nothing but 8. So have I encountered any number with 8 in my past? So that's my question. The answer is no, since I just started now. So my past data is being completely empty. So for a computational purpose, I'm just writing the complements. So which is nothing but the value of a variable here on the top of these elements. So when it's been 2, that is nothing but 10 minus 2 of 8, 10 minus 7 and 10 minus 11 followed by minus 5 followed by 10 minus of minus 2 which is nothing but 12, which is of 15, which is of 16 here. So now coming into the algorithm. So since in the 2 position itself, I didn't find any kind of previous element. So I'll be moving forward at the same time. Since I don't find any element, I just wanted to note this element along with that index, because maybe this element will help me to find for some particular, and this element might be an A or a complement for some other element. So for that purpose, I'm just storing all my past data into this hash map. And moving forward, here I just wanted to encounter if I encounter 3 value in the hash map or not. So the answer is no. Similarly, since I was just standing in the first index, I'm just mentioning that key. So I'm just moving forward. I just encountered 11. So I have not encountered minus 1. Just storing it with that particular indices. So for the clear representation, I'm just writing the indices also. So when I am standing in the 15, 15, 3, followed by here, I have not encountered anything. Similarly, here comes the thing. When it's been minus 5. So the complement is nothing but 15 itself. And the beauty is we found that complement in the hash map. So the thing is, if you find the element which is nothing but, I mean to say, the complement. So here the element is nums of I. So the complement is target minus nums of I is found in the past data. Past data. So eventually we'll be getting the past data indices itself, like past of our A, that is nothing but our complement, gives us the indices, followed by you are just standing in the ith index itself. So returning these values will solve our solution. So this is how our algorithm will be there, and we will be more focused if we have encountered any part of the complement element or not. So that is the solution of the optimal algorithm. Now we will be deep diving again with the optimal solution algorithm versus optimal solution code. So now we are diving back from the optimal algorithm versus the code that can be observed in the optimal algorithm. So since we have been given an array followed by the target, so that is the mapping function that we have been taken off. And as we know, our main intention is, since we're just looping this array, it would be good if we can write the length of the array and that can be stored in an integer. So here n will be the variable for me to store the integer of the length of the array. So here I'll be writing the array. So in this problem, in the previously as we mentioned, I'm just using a data structure which is known as hashmap and naming that data structure as a past. So I wanted to initialize the hashmap data structure here. Okay. And now my main intention was I wanted to iterate through the entire array, and I just wanted to check at every time whether I have been encountered the complement of that element if I have seen in the past or not. So I just wanted to focus on iterating through the entire array. And for every element, when I was just standing in that array, I just wanted to check if I wanted to compute the complement of that element. So since I was just standing at 0th index, I just calculated the complement on the top. So for a simplicity purpose, I just written the array indices followed by the complement names. But you can assume I can only be calculating that complement when I'm just standing at that position. That's it. So if I found the complement, the reason I'm just finding the complement is whether I had seen that complement in my past or not. So at this point, since my past has been completely empty, I have never seen that element in my past. So it's like if I had seen the element in my past or not. No, I've never seen that element in my past. So eventually what I have to do is I just wanted to store the two followed by the same index such that this may be a complement for my future elements. So that's the intention of storing the elements for the future. And now I just wanted to repeat the same things nearby the future. So when I encounter 7, I have not stored anything, like I have not encountered 3 in my past. So I'm just storing 7 followed by things, just like 7 followed by the indices of that 7. Similarly, when I'm just standing in the second index, I have never encountered -1, so 11 followed by the index I have been stored. When I'm just standing in the 15, I have never encountered -5, so the current element I'm just storing it as an index. And so up to this portion, only this whatever the code that is been present in the right side, this portion itself will keeps on executing. And when I move forward, I have never encountered 12 in the past. So I'm just storing the current data. And going forward here, I just encountered 15 in my past. So when you start encountering that element, try to get the indices of that element, which is nothing but you're just returning this one. So that helps you in getting the indices of that element just encountered and you solved the problem. So that has happened. And my intention was, what if you have not encountered, because you are just generating an algorithm, so it should be handling the edge cases also. So what if you have not encountered this element itself. Then you'll be moving forward and you'll be storing that index also, -6, followed by the index 16. And now the thing was just to end this algorithm, like you don't find any value because so you just came out of the loop and don't find anything. So just return the empty value. So this is how the optimal algorithm versus the optimal code mapping has been done. Thanks for watching.